Hi, welcome back. In this lecture, I want to introduce another kind of oscillator called FPGA. There are three key points in this lecture. The first one is that field programmable gate arrays, in short FPGAs, are the middle ground between highly specialized hardware, called ASIC, and general purpose CPUs. The second point is that FPGAs are based on CLB or configurable logic blocks that are connected via a programmable interconnect. The third point is that the advantage of FPGAs are that they are fast in receiving and transmitting, and they also provide a low power consumption when compared to GPUs. So let's look at the location that FPGAs and CPU and GPU and ASICs are. CPU provides a generic set of instructions for general computing. So that means that if we want to develop and optimize an application, we can change the code and optimize the code. However, the hardware is actually fixed. So the hardware is fixed and then we can change the code. On the completely other part of the spectrum, we have a super specialized computing devices called ASICs. That stands for application-specific integrated circuit. So some chip designer limit very much the chip functionality to a very restricted number of instructions, and they implement this instruction with the ASIC, what we call application-specific integrated circuit. So these are a specific chip that are specifically designed to solve a very limited number of workloads. An example of ASIC is the Google's TPU. That is an ASIC specifically designed for solving deep learning and machine learning neural network workloads. So FPGA here provides a middle ground between a generic processor like CPU and general computing and highly specialized ASICs. They have a very specific hardware implementation. So designer can program an FPGA chip for their own hardware design. And yet this can be changed or enhanced through FPGA reprogramming. So we can reprogram the hardware through FPGA programming. As I told you, FPGA stands for Field Programmable Gate Arrays. So why is it called field programmable? Well, it's called field programmable because we can reprogram the chip. So we can reprogram the actual hardware. And this can be done easily for a different hardware design. At a very high level, we can view the FPGA as containing blocks like Lego. By putting Lego together in a different way, and that is programming FPGA, we can create different hardware design and that correspond to different toys when using Lego. So the main point of FPGAs is that we can reprogram the chip for different hardware design. So for different kind of workloads, we can redesign the chip by programming the FPGA. FPGAs are semiconductor devices that are based on a matrix. Right? So you can see here in the picture, we have a matrix of different blocks. So this matrix contains CLBs or configurable logic blocks that are here in pink. So you see the matrix, and then you see these pink squares that each one are configurable logic blocks. These pink blocks or CLBs are highly configurable to create different logic. So we can configure them to calculate a different kind of logic. Together with the CLB, we have vertical and horizontal interconnect that we can also program. And by programming the interconnect within the FPGA, we can create a complex data path for the CLBs. Finally, there are I/O blocks in this matrix to receive and transmitting data from and to the FPGA. So what is the CLB and how the configurable logic blocks works? Well, the CLB use configurable lookup tables, LUT, to implement a logic function. So for instance, if we have a function f that is depends on a, b, c, we can actually implement with a lookup table like on this slide here. So we can define what is the input in our lookup table and what is the output, still using the lookup table. So we can configure the lookup table to mimic any logical function given an input that gives an output. Inside the CLB, the lookup tables are often followed by headers with outputs that are registered. So output register means that these are outputs that store the previous values until a new clock is applied. So the more important point here that we need to understand is that the CLB basically consists of a configurable lookup table that we can implement our logical function. So together with CLB, interconnect, programmable, we also have different blocks. Particularly, we have memory and DSP blocks. So to further improve the capability of FPGA, other blocks like memory blocks, multipliers, embedded processor and DSP blocks can be added to the FPGA. So you see in our matrix, we can add this brown square for the memory blocks and these darker pink DSP blocks. An important point is these blocks can be segmented and divided and connected through the vertical and horizontal lines that are our network that is programmable. An FPGA may contain millions of logic elements, thousands of memory blocks, and thousands of DSP blocks. Also, the memory blocks can offer more than 50 terabytes per second and cheap static RAM bandwidth. What are the advantages of FPGAs and why we might want to use FPGA for certain kind of workloads? Well, FPGA is designed to receive and transmitting a signal very fast. So the emphasis of a high-speed transceiver with many I/O blocks in the FPGA architecture is a selling point in handling visual and audio streaming data. So whenever we have an application that is heavy in visual and audio processing, FPGA might be a good fit. Another major point is that FPGA provides a customized design that usually consume less power in the range of 38 to 50 watts versus the 200 watts range that is typically in use by NVIDIA V100 GPUs. So the power consumption is a selling point for FPGA. Another potential selling point is that the system latency of an FPGA can be also shortened with customized hardware. So we can optimize for having short latency, so for the time that we want to have our data out on the network, that is the latency. So FPGA are also used for AI interference where there is a need for very low latency and the GPU might not be as good, might not have such a low latency as FPGA. So these 3 points are the advantages of FPGA. What are the disadvantages? Well, I would say that the disadvantage for FPGA is typically programming environment and programmability. So it takes special tools to do it. To program FPGA is not as simple as to program GPU. So that's one difficulty for FPGAs. We'll see that in the last part of this course that FPGA can today be programmed with the OpenCL and high-level synthesis tools. These are my last slides for this video lecture. I want to just summarize the 3 key points of this video lecture. First, FPGA are the middle ground between highly specialized hardware, ASIC, and general-purpose computing units, such as CPUs. The basic building block of FPGAs are configurable logic blocks. They are based on lookup tables, and these CLB are connected via a programmable interconnect. The advantages of FPGAs are that they are fast in receiving and transmitting, and they also provide low power consumption. One of the disadvantages of FPGAs is programmability, that is not as easy to program as GPUs or CPUs. This is my last slide. Talk to you soon.